Hello, my name is Peter, and in this video, I'll walk you through how to get started with the NCV77320 Evaluation Kit from onsemi. We'll begin on the onsemi website. Simply type NCV77320 into the search bar. From the results, click on the chip's product page. The NCV77320 is an inductive position sensor interface, which when combined with a PCB, forms a system capable of accurately measuring angular or linear positions. It is developed in accordance with the automotive safety standard ISO 26262 and is automotive qualified for grade 0. Here, you'll find documentation such as the datasheet, application notes, reference designs, and link to our coil design tool. To access the evaluation kit, navigate to the Evaluation Board tab and select the NCV77320 Evaluation Kit. This page is dedicated to the kit and includes an image showing its layout, a main board and a sensor board, equipped with two NCV77320 devices to achieve safety compliance up to ASIL D at the system level. The main board also features a 6-pin connector for connecting a custom sensor, but only one sensor can be connected at a time. To run the kit, you'll need two things: the Evaluation Kit manual, which outlines setup steps and functionality, and the Evaluation Kit software available for download as the EVK installation package. Click the download link, but note, you'll need a registered My On account and approval to access the software. Once approved, you'll receive a notification and can save the file to your computer. After unzipping the package, you'll find several components. Firmware for updating via the bootloader application. The instructions can be found in the manual. Firmware for use with a Picket programmer. A default sensor configuration files, which can be loaded and programmed via the GUI. Schematics for both the motherboard and sensor board. An Excel-based calculator to help compute the direct coupling compensation, DCC, for improved sensor accuracy. The bootloader application and the installation file. To install, run the setup file. If prompted, select Run Anyway. If you prefer not to install the software or lack admin rights, you can simply extract the zip file and run the application directly. Next, plug in the power adapter to the evaluation kit and connect the USB cable to your computer. Launch the application. If everything is connected properly, you'll see a green USB connected message along with the COM port number. If the kit doesn't connect automatically, switch to manual connection. List the available COM ports and select the correct one. Once connected, you can read diagnostic voltages and temperature from the board. Use readout for a single read or auto read for continuous monitoring. The position data will be plotted in the chart below. As you can see, the two outputs are configured by the PWL table, such that one is inverted relative to the other. You can also adjust the X-axis timeline on the right side of the GUI. The sensor supports three interfaces: analog, SPI, and SENT. SPI can operate in parallel with either analog or SENT. However, switching between analog and SENT requires EEPROM programming. To do this, enter service mode, either via the out pin interface or through SPI. Once in service mode, you can change the output configuration using quick settings and program it into the device. For the second chip, we can now use the SPI interface to enter the calibration mode. Another possibility to select SENT output is to navigate to the detail register map and enable the SENT driver by setting the appropriate bit and pressing the right button. The device is now configured for SENT output, so now we can exit the service mode and return to operational mode to check the sensor output. Useful runtime registers can be read in operational mode via SPI. If SPI isn't available, they can be accessed through the output interface in service mode. These registers include the position register, overall receiver VREC amplitude, which should range between 4 to 100 millivolts according to the datasheet, differential input amplitudes, excitation coil amplitude, device temperature, and preset current. The preset current should not be saturated at the maximum value of 255, as this would indicate low inductance in the excitation coil, preventing the sensor from driving sufficient amplitude. Although the sensors are pre-calibrated, you can perform the calibration manually, especially if you're using a custom sensor. The aim of the calibration is to eliminate direct coupling from the excitation coil to the receiver coils, which is layout-specific and generally constant for a given design. To do this, enter the service mode and open the calibration window. You can easily read the required registers for the calibration from the chip. If calibration is already present, a warning will appear. To proceed, detach the rotor from the coil structure and click Yes to clear previous calibration data. Then press Calculate to automatically compute the calibration and write the calibration data to the device. Alternatively, use Automatic DCC Calibration. This performs all steps in one click. To verify the calibration, go to Runtime Memory and read the input voltages. If the rotor is still detached from the sensor, the inputs should read 0 volts, confirming successful direct coupling compensation. If errors occur, check the failure flag registers for diagnostic data. In this example, we see flags for low signal amplitude, DCC failure, and internal error, but this is expected since the rotor is not present. After reattaching the rotor, the registers should be read twice, as the failure flag's register is latched and only clears upon readout, allowing normal operation to resume. If the Sent interface is used, Sent Messages window can be opened to read fast and slow channel data from both devices. The slow channel must be enabled in the EEPROM to function properly. To save the current position plot, click Save Data Graph to CSV. To store the current sensor configuration, click Save Content to File. The saved configuration file can later be loaded into the GUI and reprogrammed to the device if needed. And that's it. Thank you for watching, and I hope this guide helps you get started with the NCV77320 Evaluation Kit. Have a great day and happy testing.